Well, look who it is. No, I can't really see you. Just kidding. Welcome back. This is part number something in a series of videos of me going over purely functional deployment model, which is Eelco Dolstra's PhD thesis, which forms the basis for Nix. In the last video, we talked about package management. That was section 2.3. And in this video, I'm going to talk about section 2.4, which is called store derivations. Section 2.5, which is called deployment models. Section 2.6, which is called transparent source binary deployment. This covers pages 39 to 46. So in the last video, we talked about sort of end user commands about how to install packages. And this section 2.4 backs up a little bit and starts talking again about building stuff. He leads off by saying, how do we build components from Nix expressions? He says this could be expressed directly in terms of Nix expressions, but there are several reasons why this is a bad idea. He would like Nix expressions, some operation on Nix expressions, to produce some intermediate result that's a little easier for consumers of this packaging information to use to build the stuff. He doesn't want to put actual Nix files in the Nix store because, of course, he needs it. The Nix language itself is going to evolve over time. It's very rich, but that richness is not unnecessary when you just want to build a single component. Nix expressions can import stuff, so it's not as easy to identify an expression file uniquely because you may need to unwind it and import all its stuff, and just not the most efficient way to do that. So store derivations are encodings of the build actions for a single component. And he gives an analogy here. So it says this is analogous to the way the compilers generally do the bulk of their work on simpler intermediate representations of the code being compiled, rather than on a full-blown language with its complexities. Store derivations are placed in the Nix store, and as such have a store path too. Store derivations are themselves components. Might, in Nix style, different things have the same name. There are things that are in Nix expressions that are referred to as derivations, and then there are these things that live in the store that are referred to as derivations. And I think the intent is to disambiguate them by calling the things that live in the store derivations, and the things that don't live in the store just derivations. Okay, figure 2.12 outlines this two-stage build process. Nix expressions are first translated with all variability removed. So let's take a look at that. So outside the Nix store, we have Nix expressions. And we have a translation layer here, which is represented by this Nix instantiate process. That creates a store derivation. And then there's another process to build, using the store derivation as input, to build the store derivation output. And that is done through Nix store realize. So he declines to go into details about how Nix derivation expressions are translated into store derivations, because he goes into detail about that in a later section. But he says what matters is that each derivation is translated recursively into a store derivation. And in the last chapter, we talked about Nix end, so he's comparing an explicit way to do that through a command called Nix instantiate to the sort of hidden way that this is done through Nix end. And I will say that this portion of Nix is something that I haven't really had to think about. I've been using Nix for a couple of years now, and I saw these .drv files or directories or whatever they are being created inside of the Nix store, and I knew, in some vague sense that they represented a derivation. But the details of such a thing I really did not need to know in order to use Nix for this long. So this is interesting to me. So he says, if you call nix-instantiate on an expression file named foo.nix, you will wind up with this .drv file that I guess is sort of this JSON-ish stuff, basically a data structure. He says, when that happens, when we call nix-instantiate, all input derivations of hello are recursively translated and placed in the store as well. So he's not saying it's built. He's not saying that we're actually going to have a hello binary after this process. We are, this process of Nix instantiate creates this derivation file, which is basically a data structure, and all the this DRV file and all the DRV files that would be produced by the dependencies of this derivation. Okay, so inside of the derivation data structure, we have an output field, and that stores where the resulting component will go. We have an input Drvs field containing the path of all the input derivations. Those would have needed to be built to build this thing. We have an input sources field, contains the path of all input sources in the Nix store. So if we go back here to see about what a derivation looks like, this source here, building a derivation here, this source will end up as its own component in the store. It's not stored alongside or inside of the output derivation or in this DRV file or anything. It's its own thing. So that's what he's talking about there. The system field specifies the hardware operating system. Yep. So that is one of the inputs that is necessary to build the thing. It is only buildable on an i686 Linux system. Builder field is programmed to be executed, and the args field list is command line arguments to be passed to the builder. So that combining of those two things, he's saying that the builders is bash, and then the args are, he passes -e to bash plus the builder shell script, and that forms the builder. And there's the envars. So we saw in a previous chapter that attributes inside of a call to make derivation wind up as environment variables, and those are noted here. Their representations, whatever store path they evaluate to, or the string that they evaluate to, are put in here. Building store derivations. Store derivations can be built by calling the command nix store realize, which realizes the effective derivation file. So of course, this is all done behind the scenes when you use, nixenv or nixprofile or NixOS rebuild or whatever. Presumably, if we were to call this nix-store command on this DRV path that's inside the store, we would wind up with an output that goes inside the store, and that would actually hold the hello binary. And yeah, Nix users did not generally have to deal with store derivations. So yeah, this is all kind of under the hood. The relevance is that they give us a way to uniquely identify a component both in source and binary form through the paths of the store derivation and the output, respectively. So there is a path through all the store derivations that are stored in the store that represent, the build stuff that would be required to come up with the same output as the binary stuff, and then there's the binary stuff. There's both. There's a way to query the store that, given some path that's inside the store, give me all the components that depend on that component. And then this means that when we deploy this instance of hello, we must copy all 4 paths listed here. So hello depends on glibc, Linux headers, hello, and GCC. So in order to deploy this actual binary, we have to copy all that stuff. He's saying we have this closure of the output derivations, but in this section we're talking about store derivations. We have a very similar closure of the store derivation stuff. And this hello derivation depends on these other derivations, but it also depends on this builder thing and some other stuff. Copying these paths gives us a source deployment. So as opposed to if we copy these paths up here, we get the binary deployment, and copying these paths gives us source deployment, meaning it still needs to be built, but we have all the artifacts required to build it. So we could combine those two things in order to get both the binary and the source deployment. Okay, so section 2.5. The calls to nixenv build components locally and construct user environments out of the build results. We've solved if the only machine I need to deploy stuff to is my machine, I'm cool. At this point, I have nixenv, but in order to perform actual software deployment, we have to put it out somewhere on the internet, or at least get it to the machine some way, somebody else's machine. So he's saying it provides the mechanism to allow various deployment policies. It doesn't provide any way to do this. So he says some of the examples of deployment models used in practice you can manually download releases a Nix packages collection as a tar archive. I doubt that's done much anymore. Updating through version control system. These two things have sort of been melded together over time, but not really melded together. I mean, I'm not saying they've been inappropriately glommed together. I'm saying that there was and still is this concept of channels, which a channel points to a tar archive. Okay. So yeah, it's just an archive of the repo that changes over time. And this notion of channels is sort of on the wane. The more recent model is to sort of cut out the middleman here of this tar archive and use flakes, which point more directly through GitHub at a tag or branch that's inside of Nix packages. And the successful thing about his thesis here is that it has proven to what he actually said here. He says Nix in itself does not provide any specific way to do so, provides the mechanisms. So he didn't circumscribe that it has to work this way, and it is changed over time for what I would consider the better. And that is a good thing. That's a good thing. He did it right. Anyway, channels and then one-click installations. I don't think this is, you go to web pages, is sort of like the Java model of software deployment. I don't think that's really much of a thing anymore. I mean, I guess for Windows users and maybe Mac users, I suppose. Okay, so we talked about deployment models, and now we're going to talk about the policy of deploying things either as source or as binaries. And he says the Nix model, as described above, is a source deployment model. Nix expressions describe how to build components from source. So all the channel stuff, all that, all the Nix packages, everything that describes if you want to build something from source, here's how you could do it. And but he says, of course, building dependencies from sources is slow, and it's pretty shitty experience for end users. But Nix has this concept of having I guess he calls it a transparent source binary deployment model. Pre-built derivation outputs are made available in some central repository before the commands that you would run that would normally build derivation. First, check this central repository for binaries, and if something exists with the correct cryptographic hash in the central repository, it knows it doesn't need to build it. These are compressed into archives, NAR archives, and uploaded to the server. Such a file is called a substitute, since a client machine can substitute for a build, and the server provides a manifest of all available substitutes. So here's an example in that manifest. So the manifest says where the store path is, the NAR URL is, and the size of the NAR thing. Yeah. I'm unsure whether this is actually, hats off to Nix. I've never needed to know how this works. So I'm not sure whether this is actually true to the way things work anymore. I don't think these Nix push and Nix pull commands really exist anymore. But, this stuff definitely exists in spirit, because cache.nixos.org, when you run NixOS rebuild, that's where all this stuff's pulled from. I don't know if it's still done through NAR files or what. I haven't had to deal with that. It doesn't go into too much detail about what a NAR file is here. There's a service called Cachix, which implements whatever the latest hotness is for the substitution stuff that normal mere mortals can run to if they venture off the path of what's available to them in NixOS, stable or unstable. You can make your own cache and upload the results of building stuff. So anyway, Nix, when building some store path P, notices that there's a substitute for P. It'll download the substitute and unpack it instead of building from source. That's the whole point. This is good, and the point of it is that binary deployment can be considered a partial evaluation of source deployment with respect to a specific platform, and such optimizations should be invisible. So given some concrete set of inputs, the output is this binary, and if my system matches that stuff, I will get exactly the same thing as I would have gotten if I had compiled it from source, like as close as possible, unless there's some sort of bug in Nix or whatever that has some impurity in it. What I download as the binary, it will be really, really close to what I would have built had the binary not existed, had I not downloaded from cache. I don't think it's quite bit for bit, but it's damn close. And I think probably in a lot of cases it is bit for bit. So the transparent source binary model therefore combines flexibility of source deployment systems such as Gen 2 with the efficiency of binary deployment systems such as RPM, which is what's really nifty about Nix, and like, if you use Debian or Fedora or any of that stuff, people make binaries available. They'll make an RPM available, and then you can get it through DNF or whatever it is, and apt and for Debian. There's a whole other set of stuff like source RPMs. For RPMs are treated differently. It's not like when you download an RPM, if its dependencies don't exist out somewhere on the internet, that it'll just build them from source for you. You actually have to go either build the dependencies yourself, or go make sure that they're available somehow on the RPM path or in an app repository somewhere or whatever. That's not the case for Nix. If a binary doesn't exist, that's in it's essentially a cache, doesn't exist there, it'll just build it for you, which is really cool. It's really great, really great. Okay, well, that finishes up part 1 of Eelco's PhD thesis. I feel more knowledgeable than I was before I started this, which is good. I will go on to part 2 of his thesis in a following video. Thanks for watching. Bye-bye.